see, I just don't need to multiply by the design there, the design matrix. And there we go. Okay, now it works. I just did the design. I just multiplied by the design matrix outside when I shouldn't have. Simple mistake. Okay. So now that we have that, we need to find the proper values that we want. So now we have to just print the matrix, right? But we only want what's the first object in the matrix, because that's going to be the actual answer of the A, B, and C unknowns. But that'll give us the natural log of those unknowns. So to get the actual numbers, we need to raise it to the exponential. So we're going to do np.exp, and I'll raise everything to exponential of the first item in our array, which gives us, ooh, I just missing a parenthesis. There we go. Okay, so this is where we get our initial guesses. So you can see that they're close, but not close enough. So this would respond to the exponent of the Reynolds number, which is fairly close. This is for the Schmidt number, not as close, and this is the this would be A. It's not really close, but it's close enough that we can make a guess off of it. So now we just did that linear regression, and now we want to just minimize use a different method of minimizing a function. So we're gonna define a function, and it's the sum square deviation. So sum square deviation of we'll just call it x. Yeah, we'll just call it x. And we're gonna want to return the sum, because we're doing this sum square deviation of this. Sum. All right, so here we're gonna sum it, and at the very end we're gonna square it, and that'll give us the sum square deviation. Excuse me. Okay, so we're going to have our Sherwood number, right? We're gonna have our Sherwood number, and we're going to subtract the first item in the list, in the array. All right, and then we're going to multiply it by the Reynolds number to the power of the second object in the array, and we're going to multiply it by the Schmidt number raised to the power of the third object in the array. And then we're going to have to square the whole thing, and this is the sum square. Add this parentheses here. Make sure that works. Looks like it works. So now we're going to want to use the minimize function. Minimize, and we're going to use our equation sum square deviation, and it's going to be using our the numbers that were given in the problem. So A, B, and C. A being 0.023, B being 0.83, and C being 0.44. And here we are given an array that has the guesses yet again for our A, B, and C values. So this is A, this is B, this is C. A is pretty close, B is pretty close, C is not as close as we'd want it, but again, this is just guessing. using pseudo experimental data. There's an error that we introduced artificially, so it's not going to be perfect. And so now we're going to want to move on to plotting our points.